And hello. Today I'm going to do a very short and informal video on an Apple IIc, much just like this one here, that has a memory problem. So this computer turns on, has some garbage characters on the screen, and wasn't functioning correctly. So this Apple IIc here, I don't have the case. This computer actually belongs to one of the members of our local retro computer collectors club. For more information, you can visit floridaretro.com if you're a local. Anyway, so he gave me his computer because of this problem to see what I can do to fix it. So the lab's an absolute mess right now, and I don't apologize, is what it is. I'll give you a quick tour of what I'm going to do, and I'm going to go ahead and fix the memory problem. First off, I have this very rudimentary current limiting safety device. This is something that anyone messing with vintage electronics should have, as well as other measures. Certainly doesn't hurt to have a current limiter. Basically what it is a light bulb that is wired in series with the electrical outlet. And the idea there is that I could take a piece of wire, much like this one, and I could literally stick it into this outlet like this and dead short the terminals. Because the bulb is in series, it's not a short circuit. I'm going to turn the switch on and you're going to see a very bright light. And you'll see there's the bulb. I don't want to blind you, but you can see the bulb is on. And that's because the bulb is in the circuit. They're not in parallel. The bridge is broken between these two outlets, and they're separate. They're not connected together. And the line goes through this outlet and then through the load outlet. And what this does is prevents a short circuit and also limits the current that can possibly be pulled from this outlet to the wattage of this bulb. So no matter, this is a 100 watt bulb, and no matter what you do, you cannot get more than 100 watts of current out of this outlet. What's the point of this? Well, this old power supply to this Apple IIc is as old as, if not older than me. And if there's a short circuit somewhere in the computer and the supply, this is just one small line of defense to minimize the damage, because it won't be a dead short. It'll minimize the current and provide some safety in the process. So a cheap current limiter, this thing literally cost, bulb and all, I believe $5 or under. I actually got this thing, the outlet box, for 25 cents on the clearance rack at a local Walmart. So just the box alone, then it was a box, an outlet, a switch, a plate, and I cut the end off with a power cord. Anyhow, current limiter. Then plugged into that is this outlet strip, because I didn't think in my design ahead of time that the meter I want to use wouldn't fit in that arrangement with hitting the bulb. So you'll see when I turn it on, I could turn on the switch here, and then this is called a kilowatt. Man, I've had one of these for, I couldn't tell you how many years. Very long time I've owned a kilowatt. I don't know, I want to guess at least 15 years or more. These things have been around, and they were $50–$60 when I got my first one, and I got this one for $5 at a thrift store. So you can find one on the internet for cheap. These are fantastic. What this does is it tells you some very important information. I think you could see that on the screen there. Yes, you can. This is my first video, so bear with me. Sorry if it's not professional. You can see I have 118 volts at my outlet, and we can confirm that here if you want by ramming these probes into here. And yep, it all right, they don't agree 100%. I got a 117 on my multimeter, and I think I'm going to trust my multimeter because it is a pretty good quality meter. It's made by the company called Finest in South Korea. It's true RMS and pretty decent. So 117 is the measured voltage, and alright, now they're actually getting to be pretty close to each other. So yeah, anyhow, and then you can see here, you go to watt, and that's what I'm looking at. It shows me how much power I'm pulling. Right now the system is on and running. I'm going to turn it off. I'm going to unplug the transformer, and it's measuring 1 watt. I guess just it's not a very accurate device by any means. It's just a rough idea. I already reset it, got us to 0. I'm going to plug in the Apple IIc power transformer, and it usually says somewhere around 4 watts. There we go. 4 watts just idling, not running the computer. And then once I turn the computer on, it's pulling about 12 watts. So I can see here long before we reach that 100 if something's going wrong. If you look at the display here, I hope you're going to be able to see that. Not quite sure. It says Apple IIc. Yeah, I think you could see that. And it's got some garbage characters on the screen. So what we're going to do is run a diagnostic, open and closed Apple, control and reset. I'm going to let go of reset, and you'll see the color pattern, and then you'll see RAM. And now it says 0001000. So what does this mean exactly when you have this message? Now first off, I'm gonna backtrack a little, did not write a script here. This computer had the ROM 255, the original ROM, and unfortunately that original ROM was not capable of a memory test. I think it just could tell you that there was bad RAM somewhere, and good luck to you trying to figure out which of the, I believe, 16 chips are actually the faulty one. So what we did with this system is previously we upgraded it to the ROM 4X, and one of the other members of our club was kind enough to burn a copy, thanks to Javi and David for doing that. We got our ROM 4X. We cut the little tie and the little mod you have to make to the motherboard to switch from the original 255 to this ROM 4X, which is like an upgraded ROM, and that gave us the capability here to run a memory test that shows you this number here shows you which chip is bad. Now you're looking at it going, oh, it must be 8, because you go 1, 2, 4, 8 if you're reading binary, and that's not correct. It's actually not cumulative binary. It's not. This is not an 8-bit address. It's literally just a marker corresponding to which chip is faulty. So you start from the right, and it's the 4th number over. That means it's the 4th chip. So you don't read this as an 8, you just read this as the 4th chip. And that's the main memory chip. If it was part of your auxiliary memory, there would be a marker here. I think it says ARAM or something. You have to look that up. But because it says RAM, and it has a 1 there, in the 4th position from the right, moving over, that's the 4th memory chip. Unfortunately, I don't believe it's capable of detecting more than one faulty chip at a time. It stops at the first faulty chip. So we've actually been through this already, and last time it stopped and it gave us a 1 in the 3rd position. And the 1 in the 3rd position told us that our 3rd memory chip was bad, which is chip 2, because on the board they start with 0. 0, 1, 2 being the 3rd chip. And we replaced that chip. Unfortunately, at a computer club meeting, didn't have a power supply to turn the computer on with, so I had no idea if this thing was even alive after doing so. And once he got it home, he powered it up, did the test again, and sure enough found now that it's moved over. So it is not uncommon, from what I'm told from my friends, to have multiple faulty RAM chips, in these 2Cs. It was, of all the computers people tell me about having issues with. And when it comes to faulty RAM chips, the Apple IIc really seems to always be the predominant computer to have some faulty RAM, although I'm sure 2 Pluses and others are not exempt. I believe I did have a faulty RAM chip in my GS once. So what we're going to do now is we're going to go ahead and start looking at replacement of that chip. So we're going to start by unplugging the power, shutting off the transformer. To open the case is very simple. Let's disconnect. You really just take out the screws on the bottom, and then one trick I do is I fold the handle down so it acts as a stand, and then I just lift 3 inches and drop the system, and that will pop the back up. I know it seems a bit unnerving to do, but it really seems to be a good way to... Oh, that's on the 2 Plus. I retract that. The 2C is a little bit more difficult to open because the original C, I'm sorry, I don't actually own a C. I have a C Plus, so I'm used to opening that. On the C Plus, you just drop it, it pops right off, and you're done. The original C, the back panel here is kind of a separate piece, and it is a little fussy to get all the detents and get it open. So I'm sorry I can't show you that process, but I do have, as you noticed earlier in the video, another 2C here waiting to be diagnosed. So maybe I'll probably make that a second video, and then you'll get to see opening it there. So once the lid is off the system, the keyboard just lifts up. Now this keyboard has that rubber sheet. Personally, if it was my 2C, I would pull all these keycaps and take the rubber sheet out. I find it gets in the way of typing, and as it gets old in some keyboards, it can make the keys feel very mushy. You take the rubber sheet out, all of a sudden it feels just as good as the keyboard in a 2C Plus, because the main difference is this rubber sheet was to stop spills from getting into the computer, and I certainly don't think any collector at this point is going to be drinking their cup of coffee over their Apple IIc like perhaps they did back in their college days when they would have been using one of these. So we disconnect the ribbon cable, we move the keyboard aside. We've already taken the 4 screws out from the bottom of the chassis, and we can easily just disconnect the ribbon cable. It's already disconnected, and lift out our floppy drive, put our 5 1/4 floppy off to the side, and now we're looking at more the motherboard. That goes over there. These, don't discard these things. These are to connect the ground plane. They're a good thing. So they go, if you forget where they don't go on the posts where there's this circuit board. They go on the posts where you could see the metals. So there's one in this corner and one over here in the opposite corner where you could see the bare plating. So the whole point is they make contact and carry that contact to your floppy drive. So we're going to put those little rings aside for the moment. Now, one quick second. There we are. Alright, I like to use a little box. These things are a couple of dollars, and then I can keep all the little parts in little bins, so when I go to put it back together, it makes life easy. So now I'm going to just disassemble. We're going to take out the power supply. There are 2 screws up here you have to remove. So we're going to remove those 2 screws, 1 and 2. So I'm taking out the power supply. That's kind of confusing, right? Isn't the power supply the big brick on a leash over here? Yes and no. This computer does not use the modern switching power supply. It uses a linear transformer. So inside this big, giant, heavy box is an iron core transformer that's potted, and that thing's sealed shut, and I don't think you're getting in there without destroying it. But that puts out, I don't know off the top of my head the voltage, and then this is the DC supply that breaks that down to the logic level and other like 5 volts and such for the rest of the computer. So that's your DC to DC power supply. Sorry, I don't have all those voltage specs on top of my head because I'm not actually a 2C owner. I'm a 2C Plus owner. The 2C Plus, I mean, I eventually will look at getting a 2C. The 2C Plus moved to a switching power supply, so they were able to fit an entire AC to DC with all the necessary rails in a box about this big, and they just took this whole section here and put the entire power supply, because there's no more giant iron core transformer. You just put the 120 or your local voltage right into the back, and that definitely got rid of the giant brick on a leash. So we're going to take the motherboard out. We have a screw here. 1, 2, 3. Disconnect our speaker, hidden underneath there. Number 4, 5, 6, 7, 8. They put a screw here, it looks like, reinforcing where the power switch is, so that you don't get force shoving the computer when you go to plug in that power connector. So we have 8 screws, and these are all going to go. These 2 go there. These go here into the bin. Now we take one extra look to make sure we didn't miss a screw, and then we find a good place to lift. So probably just right here. You know, don't put any pressure on anything. Alright, now you have to watch out for the volume control and the speaker jack on these things. Aha! See, that's why you don't pull hard. You always look for resistance. There's our 9th screw. Okay. Always be gentle so you don't crack something when you miss a screw, because it always happens. Alright. So there's a post here, and that presents a little challenge because you got the sound jack in there, and that it's difficult to just very carefully wiggle that out just at an angle like this, and we are good to go. Very nice little diaper underneath the motherboard, just a paper tray, I guess, maybe to absorb any moisture in case there's a small amount. Maybe it won't corrode, I don't know, just a guess. Or maybe just maybe because the holes were I don't know why they did it. Anyway, moving on. Or something to catch fire when some paper underneath there. So wow, what an old board. Copyright 83. Okay, so when you look at the board, you'll see here I've already gone ahead and take a Sharpie and I've marked the chip we're going to replace. It's the 4th chip, and that's main RAM, DRAM number, or memory chip number 3, which is 0123, which is the 4th chip. Now personally, I've tried a few different methods for removing these. So you could see here, this one says Korea, and the others all have an Apple logo, so you could tell this was the last one I changed. We're going to now change this one. These chips, I've tried a few different ways to remove them. I have a vacuum desoldering station right here. I've tried putting a large blob of solder across the back. I've tried several different routes, and at the end it seemed for me that the hot air was just the way to go about it that worked the best. So I'm going to go ahead and remove this chip, and we're going to use the hot air and some flux to do it. So to start with, we're going to put liquid flux. Well, shout out to our friends over at Alpha Electronic Supply in Fort Lauderdale for their great liquid flux at a very good price. Yeah, we don't have too many electronic stores around anymore, so try to shop local when you can, so they're there when you want something without having to wait to ship it. So I'm going to go ahead and get going with my hot air. We're at 276. I don't know what temp I used last time, if this is going to be hot enough, but we're going to give that a shot. Actually, this is the point where I am going to go ahead and put some gloves on, and the reason is because this flux is very sticky, and I hate having to try to get it off my hands later. There we go. It's just this, it's great, it's just sticky. So it's like a tree sap, I guess is the idea, right? So I'm gonna take my small flathead. I'm gonna have this forceps thing. These are really cool because you can click them shut and they grab onto something and put a little bit of weight. Let's see if that'll fit in this case. I don't remember what tool I used. Yeah, it'll fit the short way. Nope, it won't. So, but we can use it as a small version of pliers to hang onto the chip, so that when it is ready to drop out, you don't want to pull the chip out. You can end up tearing a via or traces in doing that. The chip should kind of just fall out, but it doesn't hurt to have just a small amount of pressure on it. We're going to go to 325 here. I think 325 is probably a good temp. We're going to position our little thing there. And we're just going to heat this up. And see how much of a willing participant it wants to be. So actually what I'm going to do is put some fresh solder. There's my solder. A little bit of fresh solder on it. Clean off my soldering iron here, and we're just going to melt some solder. Put some fresh solder on there. Get everything melting good. Okay. Clear up, that's just ridiculous, right? So now, let's make sure we're good and drenched in flux. From a technical standpoint, there's no such thing as too much flux. However, you definitely can make yourself a headache cleaning it up later. So, let's grab my little tool here. Or we can use these crescent. That'll be easier. Bing. And the little tiny ones would be better. Alright, now that. See, sometimes the bigger tool isn't the right one for the job. You need these have a better grippy edge on them for the little bit of the chip we're going to be able to pull on. And now we're just going to heat this up. You'll notice the flux is starting to bubble right away. And if we're lucky, any minute now, it'll take a few minutes to heat up. Chip again. Yep, they're all like pins of a lock cylinder. Yep, and there we go. There's our chip. You could see the pins one by one, like the solder popping through the hole as each one starts to flow. And so that only took us about a minute or two. And there's our RAM chip. And that's that. Look at that. We got it out. You take a look at the board there. It looks clean. There's no damage, no muss, no fuss. And now what we'll do is we'll clean this up. I'm going to put a socket in because I have them now. And I'm going to go ahead and put a new chip in. So here we go. I'm going to melt some fresh solder on all the holes. Okay, let's take my desoldering gun. If you don't have a desoldering gun, you could use some desoldering braid. And I'm going to heat it up. And just one by one. I'm not going to do them sequentially because you start heating the board up a lot in one spot. So you don't want to go sequentially when you're doing anything involving a dip chip. And you'll notice we're doing a great job here. This will only take a few seconds and then we'll be done. Just vacuuming out the holes one by one. Going back and forth, trying to move around. I'm going to skip a couple here because they don't seem to have enough solder going on. Alright, we're just going to go ahead now and see these. The solder is, clean that off. The solder is countersunk and I can't get the tip of the desoldering gun on it. So it's just these 4 holes. Okay, got a nice bead on the top of that now. A note to the company who made this AOYUE desoldering station. A coiled spring was the stupidest thing they could have done. Don't they understand the principles of when metal heats up, it contracts and it cools, it expands, and when it's hot, you just cannot get the gun in and out of the holder. Maybe on the next revision they could do something about that. Send me a new little bracket that works. Alright, we're just gonna heat that up and vacuum it. Heat that up and vacuum it. You'll notice when you use a vacuum desoldering gun that when you let go of the trigger, you still hear some suction for an extra second or two. You don't want to move to the next hole until that suction stops, because the idea is you want to put the desoldering gun on the solder, wait, because you want this, not just the solder you see, but the solder in the through hole through to the other side to all flow and be molten. And if you have suction too early, you're going to just remove the very top layer and you're going to leave solder in the through hole and you're going to have to fill it back up and do it again. So you want to give it a second for the suction to stop before you move to the next hole. So you can take that second and make sure it's fully melted all the way through before you hit the button. And now we've just cleaned all 16 holes out. They look great. I could see through them from both sides. Everything looks awesome. So now what we're going to do is we're going to go ahead and take one of these sockets I got here, and then we're going to solder that in place. You'll notice here on the board the little notch, that's your pin 1. You'll notice your socket's going to have a little notch. It's not required, but it's just proper form to put it in like that correctly. Now we're going to I'm going to hold my thumb here. We're going to go around to the other side. There's a tool that I can use, possibly. Probably not. So one trick you could do is to put something under it, like this random object here, because if you put this down, you're going to notice, whoop, the socket's going to fall right out. So you need some way to hold the socket all the way in. So when you solder it, it's completely flush against the board and not partially tilted in some way or another. So just take an object that you can use to put the weight of the board on what you're soldering. This is a plastic pipe cutter. And we're going to set that like that. So when I set this thing down, the weight of the board is on the socket that has not been soldered yet, and that's going to hold our socket nicely in place. I'm going to take my soldering iron here, and we're going to go ahead and turn off my rework, and I'm going to switch over to the fume vacuum for two reasons. One, I don't want to breathe in flux fumes. Two, it's going to keep them out of the way of the camera, which is also great. So you'll see here, clean tip again. I'm just going to go ahead and we're going to tack 4 corners to hold it in place. There's 1, and then there's 2, and then we'll do 3, and we'll do 4. Bada bing. If anybody's curious, my iron is set to 375. Everybody has a different opinion on that. I try to go with the lowest functional temperature. You have to keep in mind this is a thick board. I've had some difficulties with these in the past, getting solder to flow through. 375 is a little higher to make sure. 400 I use on my desoldering gun, and I only crank this up to 400 if I'm fighting a big ground plane or something. So we're going to go ahead and solder. I could probably turn this down to 350 and that would work. But you'll notice I move fairly quickly. We're not on it all day. We go to the next one. Dwell time is a term I learned from a YouTube channel I enjoy watching called Mr. Carlson's Lab. I've never heard of dwell time. It's a good term for it, how long you hold the soldering iron onto the item, and that really is how much heat you're transferring and how far down the board that heat's going to go. Are you going to damage a capacitor because you're holding your iron on it so long the heat's moving and burning things up? So the idea is you want to be quick. You don't want to keep it heated up for any longer than you have to. And there we go, we're done. That's it. Bada bing. You got a socket. Just take a close look under my light. Sorry if it's in the way. Yeah, I don't like that. Alright, so it's always going to be one you're not going to like. So we're going to give that a little touch up. There we go. It's just flux from the solder. Okay. Don't have my microscope set up at the moment. Normally I would use it. This, to my eyes, looks good. Okay. So there we go. Now we have our socket installed. And we're going to go ahead and take our new old stock RAM I was able to obtain. You'll notice it's matched the one I previously replaced. There we go. And these are brand new sockets, so we don't need to clean them or anything. They're ready to go. And I'm going to just go ahead and put this chip in. There's a really cool tool you can get, but I've been doing this by hand my whole life. So just roll those pins in a little. But I have been meaning to one day go buy that little tool that rolls the pins in for you. So when you put a chip into the socket, something that happens is it's easy to not realize that you have one pin not in a socket and go to press this thing down and end up with a nice 90-degree right angle on your chip, one of your pins. So I'm going to avoid that. And there we go. We're going to go ahead and put this back into the chassis like so. Okay, we're going to go ahead and put our DC power supply. Yes, I have not put any of the screws in yet. I'm going to do that in a little bit here. I'm going to go ahead and put our see, happens. That's why I like to leave this latch shut. Okay, put the screws up there for a minute. We're going to play a little short game here of 52 card pickup with memory chips. Our poor little memory chips. Sorry, memory chips. 910C, is that a 91 date code? I don't know. It's not convincing. 910C. A 4-digit number I just said it was. So we have a few. They're going to go back in here. Oops. Okay. Put that aside. Go ahead and get our keyboard. We don't need the floppy at the moment. We're going to hook our speaker up so we can have our happy beep. Our keyboard up so we can send some commands. Although I believe if you power a 2C up without the keyboard, it should go into self-test mode, but that's alright. Going to hook up our video, hook up our power. Make sure that's in all the way. I'm going to get that out of the way. And I'm going to put the screen here, turn our power on. This isn't so necessary because this system we know is okay, but as far as the safety switch. But, that's a nice happy beep, and we still got garbage characters on the display. So that tells me right there's going to be something still going on. So let's see here. We're going to do our Apple control and reset. Let go of our reset. You could see our test sequence, and God bless it, look at that. And if you followed what I've said, you would know that this now means that 1, 2, 3, 4, 5. The 5th RAM chip is also defective. So you might go, you've already replaced the 3rd, you've replaced the 4th. Now the 5th, is this true? Is this correct? And from what I'm told from others in the community, that yes, it's not uncommon at all to have to replace several of the RAM chips in the Apple IIcs. So next I'm going to go ahead and replace that RAM chip, and I'm going to stop the video here because you can see now successfully we no longer have a failure on the 4th chip, and I just wanted to make this a fairly quick little video. So thank you. Comments, questions, etc. Appreciated, and hopefully I'll be able to get around to doing more of these videos as time permits. Thank you.